Hi, I am Tom Scanlan. Today we're going to talk about blockchain and where and how you would deploy blockchain. Just curious, how many people out there are using blockchain today? Anyone, anyone? No one. Okay. Interesting that you all decided to come here. So I'll make this real simple. Let's pretend that we run a grocery store. All right, how do we handle food safety? This is how we handle it. We put up signs and we say, there's no lettuce here. There's no romaine lettuce. In America, we have these outbreaks of salmonella in lettuce, and people get sick. So this is not a good way to handle food security, right? If you know that there's illness in your food, you don't want to really just put up a sign and tell your customers, right? What happens if they take that stuff home? If everything works out, right? If we've notified everybody well, then we'll get a call that there's salmonella in our food, and we'll take it off the shelf and we'll notify the public, right? And that's reporting food outbreak or food illness outbreaks looks like this, right? You detect that there's some sort of outbreak, and then we have a whole lot of people involved. There are citizens, there are government agencies, there are hospitals, there are groceries, there are restaurants, there's the general population. All those people need to be involved to get the message out, right? We all have to work together to make this system work. If anybody misses, if any one of these people fails to get the note that our food has a problem in it, then the whole system fails. All right. This is sort of a simplified view. We have here a database. So we have detected the incident, somebody's called it in, there's some paperwork that got filed, and then the food incident goes into a database, and we call that contained. That's what the system looks like today. But what if, so there's a central agency that has to run that database, and what happens if that database gets hacked or maybe somebody puts a false claim into the database so that we all think lettuce went bad. Well, it's difficult because we have to trust that central agency, and we might not be able to. What prevents that initial report from being missed? What if we just don't detect it? Then it doesn't get into the database. Or what prevents a huge food distributor from influencing the evaluation to hide an incident? So in other words, we know there's an outbreak, but we don't report it, right? That means our system is failing. What prevents a terrorist from hacking the database and making everyone believe that there's an outbreak? Or, how do we detect any of these problems when we don't have control over that database? The only reason that the food security system works is because all these individuals make it work together, right? But what blockchain does, well, and we'll skip over these, essentially what we're saying is food outbreaks can happen, and how can we improve the process of reporting these things? Well, there's this thing called blockchain, and it is kind of like a database. But what we're going to show here, in a database, what you have are all these separate entities with their own copy of the data, and they're all working together, but some of the data gets out of date and some of it's stale. Maybe this company updates their database, but this company never sees that database change. So this is what a database looks like, but in a blockchain, instead of having separate copies of the data, there's one copy, and every entity operates on that same copy. Or rather, the data is replicated, and it's part of the blockchain. It's part of the nature of the blockchain that these things get replicated. And so if this agency changes the data, that agency will always detect it. It happens. It's just intrinsic. So if I were to improve the food safety industry, here's what I would do. I would take that database that is centrally controlled, and I would change it out with blockchain, right? So now all these separate organizations can work together on the same set of data. It improves transparency into the system. All organizations can now act in parallel together. the log that is the blockchain is immutable. So we can't, bad actors can't change the data without it being noticed. And finally, this enables automation in the system. Right now, everything is manual, right? All these agencies have to phone call each other, or they ship faxes over, or they, carry a manual report around. And this system allows us to automate that. And finally, having more consortium participants. And by consortium, I mean all the people that are working together on the data. The more of them you have, the better the trust gets, because we're all watching each other's data. So blockchain can help food safety, and if we were to apply blockchain, what would that solution look like? So a typical adoption path to a blockchain application, it starts out with this consortium formation phase. We generally want to find a number of member agencies to work together, and what we do is one of those agencies organizes the whole thing, and they go out and they find partners. In this case, it would be like the government would be one of the agents, and then all the grocery stores in your state, all of the hospitals, all of the people would become part of the consortium. Okay, and that takes a long time to build, just because there's a lot of legal issues between these organizations that they have different jobs to do, and so when trying to work together on this particular application isn't always in their best interest. So it takes a long time to get the consortium, but once they do, then we go into this technology phase where we're picking the blockchain platform. Right now you might have heard of like Hyperledger and Ethereum, and VMware has a blockchain as well. So they start to pick that technology stack, and then they develop the application. This is like typical application development after that. All right, but there are a couple places people fall out. So a lot of times people will stall in the consortium building phase. Sometimes they'll go all the way through and they start developing the application before they realize it's just not going to work with blockchain. All right, so we're going to talk about this development and deployment phase, because I think we're all technology guys, and that's really what we want to look at. We're going to look at the design, develop, test, and deploy phases of the software development lifecycle. Here's a high-level picture. If we were to implement this system in blockchain, so here's what it would look like. So we've got this, it's an incident management system. We've really got two applications, two web apps. One is for reporting an outbreak of a food illness, and then one is for responding to that food illness. So in other words, this might be hospitals. So where hospitals take patients in, they say this guy has a foodborne illness, and so they'll report it, and then all the people over here, this would be news agencies or your newspapers and television news. All right, so they would know when the food outbreak has happened as soon as it happens, as soon as it's reported. And then we've got this blockchain off to the side that's kind of its own thing, right? So these applications are one part, and this is another part. And the web applications call out to the blockchain to do operations, much like a database is kind of outside of your typical application. It's a side piece. So we're going to look a little bit deeper into the architecture. When you have a consortium of agencies, they all get their own blockchain node. It's just like a database server, right? Inside that node, they have this chain storage. And a chain is just a series of blocks. It's one block after another block after another block. It's always append only. And inside those blocks are data, all right? And it's any data that your application cares about. And then there are also these blocks that contain smart contracts. Smart contracts are what allow the blockchain to actually execute code. And I'll show you in a moment what that looks like. But right now, just understand that the smart contract is a program that executes on the nodes that are participating in the blockchain network. All right, and that diagram I showed you earlier, we had the reporting web app and a responding web app, and they're all talking to their node locally. And this organization can report an illness, and it goes into the blockchain as a block. All right, and as soon as it gets in there, that is replicated to all the other participants, and so they immediately see, oh, now we've got salmonella. Somebody reported it, we immediately see it. So this is the smart contract we were just talking about. If you have blocks on the blockchain, we can write some code. This is what a smart contract looks like in code form. This is written in Solidity, which is it's like a Java E kind of language. But inside of it, we define the data that we're really interested in, and this is just we have the address of the reporter, we have a message, and we have a timestamp. So this is a very simple way of reporting incidents. All right, then another part of the smart contract is actually the report. So if I was a participant in the blockchain network, I can call this bit of code that is living in the blockchain. So the code lives in the blockchain, and I can call it and execute it anytime I want. All right, so we compile that down and we put it into the blockchain as a chunk of data, and then external applications can call that address and execute it. All right, and here we're simulating calling the report incident function from application A, or app 1. All right, what happens when we execute that code, it creates a new block with the data that is here. So here we've created a new record, we're pushing it onto the blockchain, and that's it. I mean, this is a really, really simple application. And if we wanted to deploy that, here's how I do it. We use Kubernetes to run this whole thing, and what I'm doing here is a Docker, we're making a Docker container that has Truffle. Truffle is a part of a toolkit that lets you do Ethereum blockchain development. All right, so we make a container that has Truffle in it, which will let us deploy code. Then we're going to execute. We go into the Docker container to execute bash, right? And then we've just got a shell. So here in the shell, we are pointing at this URL. This is our production URL for our blockchain backend. All right, so it's just like a database. We're going to reference that here in a moment. When we do this deploy, this is compiling the contract code down, and it will deploy it to that production URL. Okay, so here's compiling, and then it takes a little bit of time, and it deploys, and we get this address, right? This is the address of the contract in the blockchain that is now distributed to every participant. All right, so just doing this deploy sends the smart contract out, and it gets replicated to every participant. All right, and then when we run this in Kubernetes, we have a Kubernetes manifest that can point to that. This is the same address. So this is the address of our code that we want to execute. And here I'm doing a Kubernetes deployment to run the reporting service. And when you load it up in a UI, what you get is a web browser interface that goes to the reporting incident. And here we can report we had a salmonella outbreak. We have an address for our username, and we can report it. When we report it, it shows up in the log that everybody can see. So every participant sees every record all the time as soon as it happens. All right, and that is pretty much it. So some things I want to talk about are that, this design isn't the best design, but I want you to be able to go get the code. I think I have a slide here that references the code. So if you want, you can go get that code and you can play with it. You can deploy it onto our blockchain, or you can deploy it into Ethereum, and it works very, very much the same. All right. Going back to the gotchas. All right, let's see. One other really interesting gotcha is that the code, when it gets put into the blockchain as a block, it never gets wiped out. that code will be there forever. And if someone knows the address to that code, they can call and execute that code. So if you have a function that you build into your blockchain that does something bad, or you found a bug that can be exploited, that code will continue to exist in the blockchain. So you need to create a mechanism by which you can tell the function to not operate after a certain set of conditions. So I can, as the owner of that code, I can send a message to the code that says change your state so that you can no longer be executed. And it's something that you have to think about because bugs happen. In any case, the last thing here, not every application should be running on blockchain. It might be easy to think, hey, I've got a database application, maybe I could get better trust by using a blockchain. But there are some considerations about the blockchain, mainly transaction speed, like the number of transactions that you get in a database are something like thousands and thousands of operations per second. In blockchain, for example, Bitcoin, I think it's something like 7 minutes for a transaction. And then things like Ethereum, you might get, 10 transactions per second or something like that. I mean, it's really slow. And then the VMware blockchain, we've improved that quite a bit, but now you're still talking like thousands of transactions per second. So if you have high throughput needs, blockchain probably is not the right answer. But that is pretty much it. So I'll leave it open to questions, and after this, please fill out your survey. And questions, anyone? Okay. Anyway, if anybody wants to talk about blockchain, feel free to just grab me. We've also got a number of other people walking around that do a lot with it. And there's a couple other blockchain sessions that will go deeper into technical details of like the implementation. Okay, thank you.